Hi there, this is Jacob Nash Engineering Lessons, and this video is going to be on work, energy, and power. So it's lesson 6. So, I'm going to kind of go off of what is on the PLTW website. So this goes closely along to what notes they have on there. So, first we can talk about work. So, work, here's the definition that's on there. It is the energy transferred when a force, F, because that force is described by the letter F, is applied to a moving object through a distance, D. So, and it's important if it's uppercase or lowercase, because there might be a uppercase D or lowercase f symbol in a different equation you'll learn one day. So make sure you do the right uppercase or lowercase form. And the equation for work, well, first of all, work is, the symbol for work is just a W. And the equation is work equals force times distance. And I put those two little things right here because that means that it is the component of force parallel to the distance of the object. That's not always included, but sometimes you need to convert this to the SI unit. And for work and energy, this is joules. So, joules is spelled like this. And the symbol for joules is uppercase J. And so, 1 joule is going to equal 1 Newton, uppercase N, times a distance that may be in meters, but it would depend. And so something an example could be well, the example they have on there, I don't know if it'll be the same when you're still looking at it, but they say that a student lifts a 50-pound ball 4 feet into the air in 5 seconds. So that's 3 things we know. This is going to be the force. This is going to be the distance. And this is going to be the time, lowercase t. Oops, it's not very good. And that's not necessarily something we've talked about yet, and it's not relevant for this situation, really. But if you want to know what the work is, we know that that is force times distance. So what's the force? 50 pounds. What's the distance? 4 feet. That would give us that the work would be 200 feet-pounds. Remember, the units don't cancel out. You can't just put one. You can't put none. You gotta put both, because they don't cancel out unless they're divided by each other or some other reciprocal situation. So then, what if you needed to convert that to the SI units? Well, remember we said that's in joules. What you're going to need to do is convert the force into newtons, and then also you're going to need to convert the distance. And so how can you do that? Well, this was already kind of explained in lesson one, but this is the exact same kind of unit conversion, but here's how you could do it. So 50 pounds, if we want to convert that to newtons, on the formula sheet, you can see that 1 newton equals 0.225 pounds. So we put that in there. Remember, the one that you're trying to convert is always on the bottom. See? If you put it on top, that would be not good, because that would make it wrong. Then, after you do that, you can see that the pounds will cancel out. And then the answer would be 225 newtons. Then, when you're trying to convert the feet, it's the same kind of thing. So, 1 meter, M, is 3.28 feet. So then, when you solve for that, you would get 1.22 meters, and the feet cancel out. So now we have these two things. We still need to know how many joules there is. Now what we have to do is multiply these two answers. Because remember, we said that joules equals newtons times that's the formula for it. I don't know why that's going terrible. There. So that's what we need to do. So once we do that, that would be 222.5 newtons times 1.22 feet, or sorry, meters, and that equals approximately 271 joules. There you go. That is the answer. So in feet pounds it is 200, but in joules it is 271. That is work. Now, there's energy also. So energy, the definition, the literal definition, is just the ability to do work. So what are the different forms of energy that can be used to exert a force over a distance? So there's 5 different examples that are listed, and that is light, heat, mechanical, chemical, and electrical. That's 5 examples, and like I've said a whole bunch of times before, my handwriting is not that bad when I'm writing on a piece of paper, but it's just because the stylus draws not where I touch it. So there is potential energy, which is stored energy, and it has the capacity to do work by the virtue of position or configuration. And here are different examples of potential energy. There's gravitational, elastic, electrical, chemical, and thermal. There is more definitions on those, but that's not the purpose of this video. It's mostly just to show you how to do the calculations. And then the conservation of energy is that energy cannot be created or destroyed, but it can change from one form to another. I've said that before. And then, yeah, let's see here. Oh, and then there's energy lost to heat. When input energy is changed to an output energy, some of the output is usually heat energy. And these are the first and second laws of thermodynamics. So, now we can figure out how to calculate efficiency. So, the symbol for efficiency is eta, which is Greek letter that doesn't seem that like that's what it would be if you don't know Greek, because it's like it looks like an N. It just has like a long part of it, but it the equation for efficiency is energy out over energy in times 100, and that's how you can get it. So it's usually written as a percentage, and like with the efficiency for the simple machines in the last unit, the higher is better. So yeah. Okay, so then there's also kinetic energy. That's another part, and it is energy which a body possesses because of its motion, which occurs everywhere from an atomic level to that of a whole organism. And there's energy of motion and electrical energy, but that, once again, that's not the purpose of this, the actual long definitions. And that would be energy, kind of basic, but really you should go to the PLTW website, and hopefully if you're taking this course, your school has login for that, and then you can go to Unit 1.2, and then you can see your notes there. But then there's power. That's the third thing. So power. The symbol for power is just the uppercase P, and it is the rate at which energy E is expended or work is performed in time, T. So the equation for power is E over T, or W over T. That's the case. Now, the SI unit is watts, and the symbol is once again an uppercase W, the same as work. And that seems confusing, but it's not that big of a problem, because work is just a variable, and watts is just a unit. So they're not necessarily going to be put together in a situation. So you might have to convert to watts, just like how we had to convert to joules when we were doing the equation at the beginning. So then here's the equation for that. Watts, 1 watt, it equals 1 times the joules over the time in seconds in a certain case. And if we go back to the other example, remember, the answer was 271 joules. So if we were trying to convert that to watts, because we were trying to find the energy, it would be, remember, one that you can use is the work over time. So the work was 271 joules. Why is that thing being terrible? Over the time, and it's not written, but remember, it was 5 seconds. And then that is approximately 54.3 watts. So that is the basics of work, energy, and power. If your teacher has you do the activity 1.25 or 1.2.5, you may be asked other questions which may not, well, hopefully they make sense by what I said, but sometimes the equations are slightly different in certain situations, because when you have the mechanical power and the electrical power, it can be a little bit different. So when you have the mechanical power, which can be described by not that. Let's delete that. Maybe I can use this. Oh my gosh, I'm sorry about this. I'm getting a new device soon, so hopefully the stylus works better on that. So that can be mechanical power, and this can be electrical power. But it's different because in electricity you can't use those same units. You remember from the circuits, you can use current, voltage, and ohms, but obviously ohms isn't relevant to what we're talking about. But the equation that can be used for mechanical energy would be work over time, and you can multiply the current by the voltage to get the electrical power. And this is useful when you're doing that those problems, if you do. And because on that activity, you have force, distance, time, current, and volts as different examples that you can use to, like, you first are going to calculate the work. Then after that, you calculate the mechanical energy, which also is the power out, because when there's an electrical situation, it will come out as the mechanical power. So that's the input. This is the output. And so you first calculate the P out, which is the same thing as mechanical power, and then you calculate this. Then at the end you do the efficiency, which, remember that you can also use P out over P in, which would be mechanical power over electrical power. You multiply that by 100. Then that's how you get your final efficiency answer, and then you have some conclusion questions on that activity. But hopefully, if you do that, what I just said helps. But in that case, that is it for this video, and thanks for watching. And I'm actually going to put out a video soon of how you can join a Google Classroom. And you know that Google Classroom, well, I mean, you might not know this, but Google Classroom is like Microsoft Teams, which you might use, but it's just a Google version. And what it's typically for is for a class, but obviously I'm not your teacher, but I put it up there so you can join and ask questions. Unfortunately, if you are watching this in like 2030 or something, then, oh, sorry, might not be able to answer then, because I've said this before, I do not have an profession in geometry or engineering, but I definitely do know about it, and I probably could, but that's not my situation. But I will not really have the time to answer that in a while, but as long as you join in the next year or so, I probably should be able to answer your questions. But I'm sorry if you are watching this and you can't get any help, but you can still watch the videos. You just can't ask me a question that I can answer. But Hopefully, you can find that if you have a question, and you can always just put one in the comments below. And remember to like and subscribe, and I'll see you next time. Thanks.